Okay, we're talking about constellations. This is science time. We're talking about constellations. We actually are already talking about constellations. I have here a drawing of Whitley Rudloff and some trees and some stars. And I've already said the stars are effectively random, and there's no set way that we have to organize them. I just got done saying that a lot of cultures group together the stars of what we sometimes call the Big Dipper. Let me draw those specifically, and then we'll talk about why. This is not supposed to be a realistic drawing of the night sky. In fact, I've even just now lost the stars that I thought were going to be the Big Dipper. Something like this. In the night sky, why would cultures, do you think, tend to group those stars together? They're not always the exact same stars, and they're not always the same shape, and they certainly are not always the same mythology or name. But why would they group those stars together, do you think? Magic? It's a miracle? Maybe it's a miracle. No. Maybe, but that's not the most logical answer. They're bright. They're all bright, and they're kind of together, and they look like a kind of interesting shape because they're really all of them quite bright stars, and they stand out. It's not like there's no stars other than those. It's just that these are particularly bright stars, which I'll indicate in my drawing as slightly bigger. These are particularly bright stars. They, even if you're in the city limits of Crawford and there's some lights on, probably not if you're in the city limits of Los Angeles. You probably can't see any stars. But if you're here in Crawford and you have, even though there's some city lights washing out most of the stars, you still see these ones. So sometimes, and in ancient times, this would have been like a fire or a city and people have candles and torches burning, but still there would be light pollution. Lucas, I hope you're paying attention. But when most of the stars have been washed out by light pollution, you still see these ones. And so sometimes these are the only stars that you see in that part of the sky. So it's pretty natural to group them together. Same thing with, I think of also Orion, what we call Orion, but this group of stars. And this is not, as I said, supposed to be like a scale model of the sky. But we group these constellations together basically culturally. It's not due to anything about the way the stars are or the way they're organized. It's because of cultural implications. These two examples, a lot of different cultures group these two stars together, but in different shapes, and certainly with different mythology and with different names. But here's where it stops being cool cultural social studies about how cultures name these stars and where it starts being science, is that this is the way we agree upon to break up the sky. If we need to talk about some random place in the sky, a star you can see or something that you can only see with a telescope, but we need to talk about this place right there that maybe you can't even see with the naked eye, the way that we describe it to each other as professional astronomers is it's in the constellation Orion. The whole sky, you should write this down, the whole sky is broken up into these constellations. They are kind of like states in the United States of America. Let me draw that little example. I'm going to draw it down here on the land. So here's the United States of America. This is what she looks like. This is a good drawing. Don't be mean to me. This is the United States of America. It's a real landmass. Right? This is real. This exists as much as anything exists. These do not. These are made up. What do I mean by that?
There are no lines.
Yeah, they're not real lines. These are fake, fictitious lines that we just kind of agree upon. Some of them are real, like the western border of Nebraska is the Missouri River. But that's just a river. The lines are made up. We make up these lines. These are pretend lines. What about these? These are real, aren't they? What are those? What are those little dots? Towns or cities, right? The stars here are like towns or cities. These are real. The towns and cities are real. The stars are real. The sky is real. The landmass where the United States of America is real. But these lines are made up. But they help us tell us. They help us tell us, like if I want to pick a random dot there in New York State, I can say that's in New York State, and that's helpful. Because it's different from if it's in Oregon. This random dot being in Orion is different from it being in Ursa Major. So it's helpful to have the sky chunked up like this into continuous areas. The whole sky is covered in constellations. There is no part of the sky that isn't within a constellation because that's how we define constellations. But that kind of definition of constellation is different from just the lines. I'm going to say this is Pegasus. What we think of as a constellation, Ursa Major or Pegasus or Orion, is just like lines between stars. But to astronomers, it is a whole area of the sky divided up. There are 88 constellations. How many constellations are there? 88. And someone found that there are 36 in the northern hemisphere. Is that you, Jose? 36 in the northern hemisphere, so there must be 52 in the southern hemisphere. And there is overlap. There are the signs of the zodiac can be seen in both northern and southern hemispheres. And then there are some that are what we call circumpolar, which means they're around the pole. And we see the northern circumpolar constellations all the time, and the South Pole sees the southern circumpolar constellations all the time. There are really three categories of constellations: northern circumpolar, zodiac, and southern circumpolar. The zodiac everyone on Earth sees, but only part of the time. Northern circumpolar is only visible and always visible in the northern hemisphere. Southern circumpolar are only visible and always visible in the southern hemisphere. So we use these to tell about the sky. We use the constellations to say this is how we break up the sky. All the little stars have names. They don't all have special names. Some of them do have special names, like I think this one's Betelgeuse. I think this one's Rigel. No, maybe that one's Safe. These four stars that make up Orion's like shoulders and ankles are called, I don't remember which one's which, but they're called Betelgeuse, Safe, Rigel, and Bellatrix. And I don't know which one's which, but those are named stars. Some other ones, one of these is called Doobie. But then the dimmer ones, like maybe there's this star here. And it's not part of the drawing of the constellation of Pegasus, you know what I mean? It's not like, it doesn't form any of the lines of the constellation Pegasus, but it's in the box, the state of Pegasus. And so we call this one, they're ranked in order of brightness by the Greek alphabet, and then they're given a suffix. So we might call this one Tau Pegasi. Tau, which is like the maybe 16th letter of the Greek alphabet, and then Pegasi, meaning within the constellation Pegasus. Doobie, I think it's this one. We'll say this one's extra bright. This one's Doobie. Don't at me if this is not Doobie. But we'll say it's Doobie, but we also call it's the brightest constellation in this area, and we call that also Alpha Ursa Majoris. Because it's in the constellation Ursa Major, Alpha is the first letter of the Greek alphabet, and so we call it Doobie as like a common name. Just like I could say Lucas Allen, or I could say this boy, the second child of Jared and Angie Allen, right? Isn't that true? Yeah, so it's kind of the same way. He has a common name, Doobie, but he also has a designation, Alpha Ursa Majoris. And they're ranked how? By brightness, which we also call apparent magnitude. Apparent magnitude. What does apparent mean? How it appears. Apparent magnitude is how it appears. From where, probably? Earth. Yeah. It'd be crazy to do that from anywhere else. But apparent magnitude is a factor of absolute magnitude. What might that be? For a star? No? That's going to be the next thing. Distance. How far away it is. But absolute magnitude is how bright it actually is. How bright that star is actually in reality. Like if we were 10 feet away from it, how bright it would appear compared to being 10 feet away to another star. Well, that wouldn't be a good idea. But if we were a light year away from it, how bright it appears compared to being a light year away from other stars is the absolute magnitude. So what would increase the apparent magnitude? Changing what about the absolute magnitude would increase the apparent magnitude? No, making it brighter. Brighter stars have a greater apparent magnitude for a given distance, and closer stars of a certain apparent magnitude have a greater apparent magnitude than far away stars do. So the closer and bigger a star is, the higher its apparent magnitude. Anyone know what the brightest star in the sky is? No, it is not. No, come on. This is a trick question. The sun. The sun is so bright that these things still exist. All this is back here. You just can't see it anymore because the sun is so bright. It's like the epitome, you know that word, the epitome of light pollution. It's so bright you literally can't see even one other star. So that's the sun. That's the brightest star. The second brightest one is Sirius, which actually, in this drawing, I know that Sirius is in the constellation Canis Majoris, which is Latin for the big dog, which is probably some of your football nickname. Probably Wes, Big Dog Lindquist. So this is Canis Majoris, which we would call this star Sirius, or Alpha Canis Majoris. This is the brightest star in the sky besides the sun. And it's so bright that that's why the Greeks, when, not all of them probably, but they thought that's why summer was around. Because to them, in the northern hemisphere, this is true, that when you can't see this star, it's the summertime. And so they thought that this star's brightness was combining with the brightness of the sun, and it was making it really, really hot. That's why it's called the dog days of summer. This is the dog, the big dog. It's called the dog days of summer because to the Greeks, when this star and the sun were in the same part of the sky, it was super hot. It's also why Sirius satellite radio is a little dog with a star in its eye, because this is the eye of the constellation Canis Majoris, is Sirius. Probably. I don't know what you're talking about, but I bet you're right, because Sirius is associated with dogs because of that. The main thing to take away from this is that the constellations are kind of like states. They're made-up lines that cover an area. They're not just dots with lines between them. Okay, does that make sense?